Hey there, Dangar here. I don't always diagnose outboard trim tilts, but when I do, I start by checking the battery. So there's plenty of ways to test a battery. I'm just going to use this battery tester I've got, but you can just use an ordinary multimeter. Just going to scrape a bit of this protectant off so I get a clean connection. We can see here this is already giving us 12.9 volts, which is pretty high, so we say OK. And this is actually an in-vehicle test. It's before it's been charged, it's regular flooded, we're on the top post. It's measured in CCAs and it's a 640 CCA. And it'll go off and do its little test. If you're just using a normal multimeter, a good way to check a battery, so this is saying the battery's good, is to put your multimeter on the battery, get a reading, then just turn the motor over and see whether that voltage drops down. You really don't want it to drop much below that 12 volts for it to be still a good battery. Before we start, I should probably have sort of told you the symptoms. In this case, it's that you can operate the switch, you can hear the relay clicking, but nothing happens. So this could be a case if the battery was low, there's enough power to activate the relay, but not enough power to activate the motor. But in this case, we know the battery's good, so we're going to sort of trace it forward. Now, the power from the battery comes in and attaches directly to this start relay. So this is the shortest path for the thick cables to go. Thick cable into the start relay, thick cable out to the positive of the starter motor. But this is a really common place where power gets tapped off. So this is one power lead that goes to the front of the boat and powers a lot of the sort of, devices and things on the boat, which has a fuse on it. So if you had a fuse going to your relay, you could check that. This wire here comes off the same positive terminal, and it supplies power here to the relay. Now, it's a little bit exposed here, so redoing that wire mightn't be a bad way to start, see whether you get a result. But what I'm also going to do here is just start testing a few of these. So if I attach this meter here, I see I'm getting 12.9 volts through to the power input on the relay. So that's the power that drives the motor. So far I know I'm getting power to here. Now, having 12.9 volts doesn't mean you're getting much current. So if you've got a really high resistance in this line, you may not be getting much power through to here at all. Maybe 12.9 volts, but at a very low current, or getting very low amp reading on there. Now, we can do that, test that using a voltage drop, which I'll show you in a little bit. But for now, we're just going to see if we can see any area where we're not getting power at all, and then we'll sort of finesse it from there. Alright, I'm going to try and do this holding the tester and the camera in one hand. But what we can see here is, so this is our power in, and then we've got a blue wire here and a green wire here. So these two wires, the green and the blue, they're the two wires that go to the motor itself. So if I touch the green wire here and then hit the up button, so in this case I get, this motor's actually starting to move a little bit now, which is an interesting clue. But if I hit down, I'm getting 12.6. If I hit up, I get ground. If I come to the blue, if I hit up, I get 12.67. And if I hit down, I get ground. So what it means is that these two are getting power through, so the relay is working correctly. So coming up, I'm getting power to blue. Coming down, I'm getting positive 12 volts to green. And they act as the ground for each other each time. So two wires to the motor, current flowing one way goes up, current flowing the other way goes down. So what we know now pretty much is this relay has a clean bill of health. Now, the smaller wires you see coming to the relay, they're the activation wires. They're the ones that come from the switches. So here you can see this is the trailer switch, the switch on the side of the outboard. Same thing up at the forward controls. Is you've got power coming in, and then the switch either sends it out one wire or out the other. And then depending on which wire it goes out, it activates the relay in one polarity or the reverse polarity. So if I just pull, this is the connector for that switch. So if I pull this out and disconnect this, hang on, I use two hands to do that, and I'll be back to you. So what this means is that bottom pin is your 12 volt in, and then you should be able to test for continuity between the bottom pin and the top left pin and activate the switch up or down and have it come on for one of those, and the bottom pin and the top right and up or down and have basically zero resistance. So it's the same way you test any switch, just make sure your switch isn't at fault. So if your relay's clicking, it's obviously not your switch, but if your relay wasn't activating at all, then test your switches front and back by testing continuity across the switch. And that way you can rule them out as being a problem. So in this case, we know the switches work, we know the relay works, and we know the battery's good, so we got that far.
So we know now that we're getting power coming out of the relay towards the motor. Now another really common thing that can happen is that wire between the relay and the motor itself can be cut in some way. It's one of the most exposed wires on a boat, really, particularly with the outboard sort of coming up and down. If it's not well secured, it can actually get scissored in the outboard bracket. So just do a visual inspection of that cable as well. But what I'm going to do now is see how much that current's making it all the way to the motor itself. And to do that, I need to trim the motor up to get to it. Obviously the trim's not working. So I'm going to go in and just open up the hydraulic bypass and then use an engine hoist to lift the leg up. The leg's not that heavy, you know, you can use anything. I'm using it because it's here. You could use a ratchet strap, just a rope, whatever, something to hold it up again. So I'll show you how to bypass the hydraulics and then we'll lift this motor up.
So this here, you can see through this hole in the bracket is the little valve for bypassing the hydraulics. So I'm just going to turn this. In this case, it indicates counterclockwise. Right, you can just see the outboard drop them, and that's showing that the pressure is now released. So instead of having to go through the pump, which will hold it, I can now physically move this motor. So all I'm going to do is put a rope around the base of the leg here, and then just lift it up. Many motors have a little stand you can put down here when it's chilled up that'll hold it up. I don't have one on this bracket, so I'm going to use the stand to hold it up the whole time.
Alright, now it's tilted up, I'm just going to leave it supported on that the engine hoist because it doesn't have any sort of brackets on it, but I'll show you in now and where the wires go and what we're going to need to check.
So now it's come down, these wires just come into the top here. So you've got your hydraulic ram here, the hydraulic pump, and the electric motor that drives the pump. Now this motor is attached with Allen keys on here. So I'm going to go grab some Allen keys and I'm going to take this motor off entirely and then I'm going to just try and drive this motor while it's isolated from the system. So once again, just to see how it performs without this load on it.
So here's the motor out of the outboard now. I'm just going to give it another go with the switch. You can see actually then it spun the first time. There we go. Tries to turn. So to me this is clearly an electric motor problem. We know there's nothing wrong with hydraulics. Well, we don't know that from this test. I'm pretty confident there's nothing wrong, but we do know that there's a problem with the electric motor. If this was spinning away freely, wouldn't necessarily mean there isn't a problem. It may mean that we're getting low current due to a high resistance somewhere in the line. The motor's turning consistently, but it's not strong enough to turn the hydraulics. But This to me is a problem with the brushes in the motor because it's very intermittent. It's like you're sort of getting a little bit of connectivity, then nothing. You know, that just turned a few degrees then. So I'm going to take this motor apart. We're going to test the armature and then have a look at the brushes in it. So before I do that, I'll just quickly show you the rest of the hydraulic system. So you can see in here, there's the oil reservoir. This here is the fill plug for that. So this is the fill level, and you can see it's pretty much up to that fill level. If that was empty, that could be a part of the problem. So if you've got no hydraulic oil, obviously a hydraulic ram can't work. But if it is empty and it has been working, then it's obviously gone somewhere. You've got some sort of a leak. So don't just go, I mean, you can add oil and see how it goes, but you've got to investigate where that oil's going as well. So we've got good oil. This video is not going to go into reconditioning these hydraulic pumps. They're actually relatively complicated, and I've never done one myself. It's something I would send off to do. But, you know, down the track I might learn a bit more about those. But in the meantime, we're going to stick to just looking at this electric motor. Sorry, it's all a bit of a jungle in here, but to get this motor over to the bench, I'm just going to disconnect these blue and green wires from the relay that we looked at earlier. Once they're disconnected, I can just pull the wires out here through this grommet and get this motor out to the bench and take it apart. So there's just 3 fillets and screws that hold this flange onto the motor. So this casing has the permanent magnets in it, 2 permanent magnets. This part here has the brushes, and this is the armature. So what we're looking at here is we're going to test the armature first using a multimeter, and then once we've tested that, I'll have a look. These brushes actually look like they've got, I don't know how well you can see them. So the brushes are these 2, we call them brushes, but actually kind of a solid metal, and they're backed by some springs that push them out. So there's a few things that can go wrong. One is that the brushes just get a lot of carbon in, so they can wear right down. So these will actually wear as the motor spins. They can wear, they can clog up with debris like carbon from as they actually wear down can get in here, so the springs aren't strong enough to push them out, so they're making an intermittent contact down here with the commutator. So what I actually do is pop those out, clean up that area as a matter of course, but in the meantime I'm also going to do some tests on this. Now these sections on the commutator are supposed to be independent of each other. There's quite a bit of debris in these grooves too, so I'll also clean this up a little bit. So I'm hoping that this could actually end up simply be a job of cleaning this motor up as opposed to replacing any parts on it. Okay, so I'm going to clean first, then we're going to run the tests, and then we'll reassemble and see how we go. So to clean this, I'm going to start with just a little brake cleaner. It's just a cleaner that leaves no residue, which is perfect for this. Just going to give it a light scrape between each of the commutator bars. These are the bars that those brushes rub up against. Alright, so that's already looking a lot better than it was. These gaps between here were gummed up with a lot of debris and they shouldn't be shorting against each other. So once I've cleaned the gaps, I'm actually going to clean this surface up too, because once again, as I was saying, this is the area where the brushes actually contact up against. So electricity needs to pass from those brushes to the surface of these commutator bars. So I'm going to clean this up a little bit, get that a bit brighter, and then we're going to do these tests. This is just a bit of clean rag. It's not sandpaper or anything. I'm sure you could probably get away with a light, very light sand with very fine grit, but this seems to be getting a lot of that dark sort of carbon material off anyway.
So the three tests I'm going to do here are testing what they call the 180-degree test, where you test the commutator bars that are directly opposite each other. So in this case I'm getting kind of, what's that, 2 ohms roughly, and we can rotate round and go again, so 2 ohms roughly, and you work your way around. Now your particular motor will have a particular value it should have, and that's almost 2 ohms exactly again. But the point really is they should all be quite consistent. If one's widely out from the others, you know you've got a problem. Then once you've done that, you can test 2 neighbouring. In this case we got 1.6. Out to about 2 again. Higher on that one, but once again this is a very pinpoint touch, so even scratching it can give you a slightly different reading. Then once we've done that, the center of it is ground, and so if we touch this center post, then all these commutator bars, we should get open circuit on them. So that's actually showing like 32 mega ohms, 34, 34. So these seem to all be consistent in about the 30 odd mega ohms, which I'm considering enough resistance to be considered functional. So next thing I'm going to do is pull those brushes out, clean in there, and just make sure no dust is stopping the springs from pushing the brushes out to touch against here. So normally when you're putting an electric motor together, you've got quite a bit of trouble pushing these springs back, or these brushes back against the springs, and getting them to stay there. These are really, really stiff. So I think this is probably our primary problem. These have worn down as the armature spins, and then the spring's not pushing them forward to touch the armature. So I think we're pretty much on the money with what's wrong here now. So I'm going to pop them out, have a look at the springs. May need to replace them if they're damaged or weak, but it could just be a bit of a clean up once again is all this needs. Those back slightly. Alright. So as you can see, these brushes, as well as being quite gummed up, have actually still got quite a bit of meat on them. They're a bit like brake pads, I guess. They rub against something intentionally, and they eventually wear down because of it. And these are the springs. Once again, you can see they're very gummed up. So I'm just going to clean all this up, reassemble, and then just see how freely they move. So I'm actually giving the sides of these brushes an extra little scrape. They've got a lot of quite tough residue on them, and this is all the residue that's going to make them not slide properly. I don't know if you can see that clearly, but there's quite a lot coming off here. Now comes the tricky bit. Putting this back in here and getting the brushes back while you do it. So the brushes need to be back and out of the way. Actually, I can already see a bit of a problem in that this needs to be out of the way too. Alright, so I just then I pivoted this. I had this sticking out here in the way. It's
stupidly. So I've just rotated that round, so we're now clear. But we now need to slide this down. So the way this actually one's not too bad. You've got a bit of access to the side. So the trick really with this one, it's a little bit like picking a lock here. Keep a bit of pressure on it. Keep pushing down and slide them. And that way, whichever one goes first will go and it'll hold it, then you just keep pressing. So that's in now. It's rotating against the brushes that are now free to move, and therefore the springs will be pushing them against those commutator bars. So the current can pass from these wires into the windings of the motor. So obviously we haven't tested yet, but having seen that visually now, I'm pretty confident that's what's wrong with this trim tilt. Sorry, this has gone from being oh, magnets in this make it awkward to get on. Gone from being a bit of a thing about trim tilts to being a thing about electric motors. But, you know, that's a big part of what a trim tilt is. Alright, let's sit back together. Let's go pop it back into the trim tilt mechanism, feed the wires back through and give it a test. So the only real trick to popping it back in is the orientation, obviously, of I'm going to feed these wires through first. I'll put the camera down when I do that. Is that on the end of here you've got a little flat blade, and that needs to slot into the hydraulic pump. So it might take just a bit of twisting to get the right orientation for that to go in. So I've got the wires through now, and I'm just rotating this until I get it to drop down. And if it's not doing it for the angle of movement you've got, just get in there and manually twist it a bit. Try a different set of angles. There we go. So that's now aligned, and if it's dropped down, then that blade must be aligned with the female socket on the hydraulic pump. So I've got the wires fed back and reconnect to the trim tilt relay. Really important thing now is to re-cable tie this to the bracket here, because you really don't want this floating around here. As you can probably tell from the huge chunk of tape, this has actually been cut before. So pop it in here. So I'm going to cable tie that and then we'll give it a test. Alright, moment of truth. Oh, hang on. That's what I need to do. Is close this valve again. So if that valve was open, the motor would run, but the hydraulics wouldn't move because it would just be pumping hydraulic oil through the bypass. Okay, so I think that's right at the top of its travel. So I'm going to let this crane off and we'll give it a proper test. Alright. Okay. Fixed. So, I'm actually quite pleased about that, it's my boat. I guess the real take-home message from this is, like everything, start at the beginning, work your way through. Hydraulics per se are complex in that there's quite fine tolerances inside the hydraulic pump. As I said before, I'm no expert on those, I don't pretend to be. But 9 times out of 10, if not more, the problem's something much simpler. And like all diagnosis situations, just start at the beginning. Is my battery flat? Is power getting to the relay? Is the switch working? When that switch is activated and the relay doesn't click or not? If it clicks, is power being supplied to the blue lead, to the green lead? Is that lead cut somewhere? Is the motor working properly? In this case, just needed the brushes cleaned up and freed up, actually, and the commutator cleaned up a little bit. Is there hydraulic oil in it? So they're kind of the main things. Is the ram stuck in some way? Is that bypass valve just left open? Can I hear the pump turning, fluids in it, but it's not going anywhere? Maybe just close that valve, it might be left open. So there's a few things that can go wrong, but just take it one step at a time. Start at the beginning, start the battery. Use an electrical system predominantly. One thing I didn't say putting it back together is, water ingress inside this motor is obviously sort of a bit catastrophic for it, and they are quite close to the waterline. So be sure the O-ring's in good condition, maybe put a bit of rubber grease on that O-ring as well, and make sure that you nip it up pretty tightly when you put the casing back together, and then the flange back onto the pump itself. So hopefully this video helped you. It is a pretty common problem that people have failed trim tilts, and it's kind of frustrating when it is. So I hope this sort of diagnosis process can help you fix yours. So thanks a lot for watching. If you enjoyed, please subscribe, and I'll catch you next time. See ya.